Welcome back to my channel, Knowledge Spread by Sir Boots. This time we are going to have a problem on the present and future values of general annuity. The difference between the simple annuity and general annuity is that in simple annuity, the compounding period is the same as the payment period. This means that during the payment period, the compounding happens, the compounding of interest happens. And in general annuity, the payment period is not the same as the compounding period. So meaning the time of the compounding period does not jive with the payment period, the time of the payment period. So there is a need to convert the the rate per compounding period into the rate during the payment period. But remember that the future values of the general annuity during the compounding period and the payment period are the same. The only difference that the compounding period does not happen during the payment period. So there is a need for converting the rate during the compounding period to the rate during the payment period. So we will again define so that we can remember the terms in the general annuity as well as the simple annuity. So annuity, it is a sequence of payments made at equal or fixed interval or periods of time. And general annuity, the annuity where the payment interval is not the same as the interest period. So term of payment is the time between the first payment interval and the last payment interval. And regular or periodic payment is the amount of each payment. Okay. Amount or future value of an annuity is the sum of all future values of all payments to be made during the entire term of the annuity. So that's it, no? So the terms for the used in the study of the annuity. Okay. So let's have the next slide. In order to solve both the present and future values of the general annuity, there is a need to convert the interest rates during the compounding period to the interest during payment interval. So we have example. Mrs. Herrera saves 2,500 monthly for 3 3/4 years in a fund that pays her 6.4% compounded quarterly. So, Mrs. Herrera saves 2,500 monthly, but the compounding happens quarterly. So, in the problem, the interest is compounded quarterly, but the payment interval is monthly. So there is a need to convert the interest rate during the compounding period to its equivalent rate during the payment interval. How to convert? Okay. So in the problem also, the future value generated upon compounding period is equal to the future value generated during the payment period. So their future values are just equal. No, the compounding, the future value that happens during the compounding period and the payment period. So in this case, we can have F1, F sub 1 equals F sub 2, meaning future value 1 and future value 2. This future value 1 is the future value that happens during the payment period, and this F2 is the future value during the compounding period. So the future value is P times 1 plus J or IM over M raised to MT. That is the future value of the compound interest rate. We will use that in the conversion. So since it is a monthly future value for monthly payment, we have 1 plus I 12 over M, which is 12 raised to 12t. And this one also, future value during the compounding period, you have the given nominal rate, no, which is 6.4% or 0.064 in the decimal. Since quarterly, that is over 4, and raised to 40. So that we can free the J here. This is equal to Ji to the 12 over 12. This is the rate rate that compounds during the payment period na, and this is raised to 12t. In order to free them, free the J here, we will cancel P and divide 12t. No, the exponent divide by itself, 12t divided by 12t. So also with in the right side, we have to the exponent 40 divided by 12t. As in such a way, we can free the 12 over 12 here, which is J. That is what we need, no? We'll convert the rate into that. So since 12t divided by 12t, that is already cancelled. So this 40 over 12t is, this is equal to 1/3. So here we have I12 over 12 is equals to J. So J now is equals to, you compute this one by calculator, that will give you a 1.016 raised to 1/3. We transpose, or by virtue of the addition property of equality, we have 1, we will transfer it here, -1. Change the sign. So J becomes 1.016 raised to 1/3 minus 1. So we just calculate that in the calculator. So we can get J is equals to 0.00535051. And 1 plus j is equal to 1.00535051. So that is what we need in getting the present and future value. That is already the converted rate, from the rate during compounding period to the payment period. This is now the rate which will be used for computing the present value and future value of the general annuity, which is during the payment period. So now the computation now for the present and future value, will use this j. Okay, so the formula for future value of an annuity is given as f equals r times 1 plus j raised to n. This n is empty, minus 1 over j, where f is the future value, r is regular payment, n is empty, m is frequency of conversion in a year, t is the number of years, and j is rate per conversion period. This is period, that is d. Okay, equals I to m over m. And I to m is nominal rate or annual rate. Okay, so let's go to the next. So let's repeat the problem so that we can get the data. Mrs. Herrera saves 2,500 monthly for 3 and 3/4 years in a fund that pays her 6.4% compounded quarterly. In the problem, the interest is compounded quarterly, but when the interval is monthly, there is no problem. We had resolved that already for solving the j. So the data is r equals 2,500 and j is equals to 0.00535051, and 1 plus j is equals to 1.00535051, and n equals mt equals 12 times 3.75, because the year is the t is 3.3 3 and 3/4 years, that is 3.75 in decimal, that is equal to 45. So we substitute all that values to the formula. We have the formula f equals r times 1 plus j raised to n minus 1 over j. So f is equals to 2,500, that is our r, and our 1 plus j is 1.00535051 raised to 45 minus 1 over j, which is 0.0053051. So by using the calculator, we solve the future value f to be 126,686.66. Okay, and we can also find the present value of the general annuity using the formula for the present value. Oh, this is not the formula, so we'll change this one. This is the formula is wait, this is not the formula. So there is no minus 1 here, but here 1 minus 1 plus j quantity raised to negative n over j. So that is the formula. Formula for the present value is equals to r times the quantity of 1 minus the quantity of 1 plus j raised to negative n, close parenthesis, over j. So we substitute, we have 2,500, open parenthesis, 1 minus the 1 plus j is 1.00530051, close, raised to negative 45 over 0.00530051. That gives us P is equals to 99,844.93. So, that is how to get the future value and the present value of the general annuity, given that the compounding period of the general annuity is not the same as the payment period. But we can resolve that problem by converting the rate during the compounding period into the rate during the payment period. So, that's all for this video. Bye-bye.